All right. Let me go ahead and get all the stuff going here.
Get
Pop
your
the
cue
chat
cards
out.
ready.
Yep, getting everything ready.
Getting the
Let's
audience
see.
applause sign ready at key points.
Laugh now, you sons of.
Yeah.
All right. So let me take a peek here on the stage. See. Okay, looks like we are live now, Hunter. All right.
Perfect.
So I'm going to disconnect quietly there. I'm going to pull up the old chat box. What's going on, everybody? Folks on Discord, folks on YouTube. There are people everywhere coming out of the woodwork
Woo!
to get their questions answered. Hunter, I hope you're ready with some satisfying answers.
My mind is blank and my brain is open.
Mind is blank. That just means you're in like a Zen state, right? No thoughts.
Yeah, I'm actually doing pretty good. Not too bad.
Excellent, my friend. And before we get started with the questions, just want to go over the rules with everyone real quick. If you are new here, we have office hours every single week. People are able to ask their questions, but in order to get your question answered, you actually have to be a channel member on YouTube or you have to be a member over on Discord. It's $3 both places, and it gets you access to lots of awesome perks. So, whichever platform you choose to become a member on, you are going to really like what you get for that small amount of pocket change. I mean, dude, I get a black coffee when I go to Starbucks. I'm talking just like, because they have the stupid sizes, whatever the small is, the tall. I get a
Hmm.
small black coffee. It's like $3.25. You're literally getting a month's worth of perks, getting to talk to folks like yourself and our other awesome coaches and live streams and Discord channels and getting videos like 6 months early before we release them and all that jazz for less than a small black cup of coffee at Starbucks. That's freaking crazy.
That's not bad. That's not bad.
Nope, not bad at all. I see people are calling me Gabriel Hardbargain. That'd be like my that'd be like
There
my
you
Lord of
go.
the Rings game where
Yes.
they name people based on Gabriel Hardbargain. I like that. I
Beautiful.
I like that a lot. We should probably start off here today, Hunter, before questions start coming in. We should talk a little bit about what's going on over in New Jersey because actually one of our internal staff, Green EWX, people know him from the various live shows in our Discord community. He
Hmm.
is actually chasing because he's from New Jersey and he was on that PDS storm that went through Dover.
Yes, that one was kind of a quick hitting tornado there. I was focused on other things at work, but I happened to glance over at the radar at the time and go, "Ah, look at that! That's neat. I should probably pay attention to that." And then by the
Yeah,
time I recognized that, it was already ended.
well, Hunter, if you wouldn't mind, would you be able to maybe pop open Weatherfront real quick and just maybe give us a quick analysis of what you're seeing?
Sure, absolutely. Let me go ahead and share my screen here.
Oh,
Move.
always fun to do this because usually we're either talking about forecasts in the future or we're talking about something that already happened and we're kind of given a what was it called, like a post mortem on the event. But it's really cool to get to see you coaches in action. So very rarely do the stars align and we have something going on right during a show.
Yeah. So fortunately, I hope everyone can see this. Everyone can
Yep.
see this, right? Cool. So this is Weatherfront, and I hope you guys are very familiar with this amazing platform, and we use it here a lot at Storm Chaser Coaching. But fortunately, for those out kind of in the area, most of the severe weather has pretty much started to die down, thankfully. We do see this nice big bow echo finally kind of shooting off the coastline there of New Jersey. But yeah, there were definitely some tornadoes earlier today, and that's kind of a fun thing. So let's take a look at kind of what happened synoptically about kind of, what caused maybe this tornado to occur here. So we're just gonna pull up, just take a layman's look here, just real simple. It happened about a couple hours ago now at this point, so let's go ahead and just we'll take the 20Z her, just kind of get a base idea here what was going on. If I remember correctly, I'm trying to remember exactly where the tornado occurred. Remind me, which state was it in? I know the time was Dover, correct? I'm trying to remember where
Yeah,
specifically.
yeah. It was Dover. Was I think Dover
Ah,
was the CC drop, I believe. Correct me if I'm wrong, people in chat, but that's what I think I saw was a CC drop over Dover.
There we go. Yeah, Dover right here. There it is. Okay, perfect. So yeah, a little CC drop picked up, which was what caused the NWS to kick off the obvious tornado warning, and then the reports of tornadoes in progress. They obviously kicked it up to a PDS tornado warning, which, to be fair, perfectly fine considering there was a tornado moving through a populated area. Great warning to have in that case. So pretty much and I actually kind of funny enough was a little curious about how this forecast was going to go. I know Andrew did a forecast for today's stuff. But the one thing that kind of tipped me off about kind of what may occur was the idea that these tornadic storms will probably be occurring more so around the kind of shoreline areas, which made me immediately think, hey, is there going to be maybe like a lake breeze or a sea breeze boundary kind of in the area to provide that like stronger helicity in maybe a localized area? And actually, funny enough, this was actually well picked up on last night. If I should go over here we'll go to yesterday's model, the zero Z. I think I was looking at it. And while I don't use this necessarily verbatim, I do like have showing this to get like kind of a easy point of view is using the significant tornado parameter because it does a pretty decent job at like highlighting maybe some key little zones of interest. And notice even last night with the zero Z her, it was kind of signaling that maybe these little lake breeze boundaries sitting in here, and I'll draw them so they're a little bit easier to see, kind of, along here. I keep saying lake breeze. This is a bay breeze, sea breeze. You get the idea. It's water blowing cooler air onto land. You get the idea. But
You've seen one, you've seen them all.
they're the same thing. They're the same thing. It doesn't matter. But yeah, it seems like there was this signal of getting these highlighted zones right along the bay and little channels here where you have higher moisture because obviously there's a water source there. So if it's baking in the sun, you'll have a localized area of higher moisture. But notice also the geometry of the bay here as well. This is a pure southeasterly fetch that air will kind of funnel up through here. So this naturally gives you a little bit better turning of the winds. And again, no shock here, kind of a more south-southeasterly flow here. So if you get a supercell to kind of track along in here, it can suddenly experience winds that are going from, say, maybe more southerly to a little bit backed as well to more southeasterly, or maybe south-southeasterly here. So I don't think this is too much of a surprise here in this case that at least last night, the models were indicating that that could have been a possibility. SBC did denote that there was going to be a tornado risk, and actually, if I can remember how to do this, it's under Outlooks. I wonder if I can see past ones. I don't know if I can. But previously, they had put out a tornado, 5% here, which then they upgraded earlier this morning to a hatch. So basically saying that there could be a potential for EF1, EF2 type strength tornadoes. And I think the one that hit Dover is probably going to be in that EF1 to EF2 range, especially just given the overall debris ball and CC drop signature, usually indicative at least of a modest tornado in progress, at least. But since it likely went over a populated area, where it actually went over, I know I'm circling kind of areas I don't actually know for sure. But there could be, some type of tornado pass somewhere in this general vicinity that was obviously lofting enough debris for the radar to see. So I'm very curious to see what that tornado will end up being rated. I don't know too many other tornadoes there were. I know Reed Timmer saw a water spout as well, which looked a little bit mesocyclonic, but otherwise, I don't really think there's been a handful of tornadoes today, which not too bad. We don't necessarily want damage, but it looks like the tornado risk at least was satisfied here. But taking just a quick look here, pull this stuff away. Let's stop drawing on the map because I'm a goober. Beautiful. There we go. Let's just take a look kind of what was happening from a top-down perspective. Pretty much at the overall time, and actually I'm going to use let's go ahead and just use the 18Z her here. So basically by the time of interest here, right, we're getting into the afternoon. We've got a nice little jet streak max that's kind of just tailing in here, which is the impetus of our severe weather. You do get a bit of a short wave that kind of arcs in like this. So there was some influence coming in through here. So you get lift out ahead of it generally. Even though we're looking at our general dynamics here, this wasn't necessarily the most favorable for maybe rotating storms per se. This is just a pretty nice straight jet, which we can do our jet dynamics on. The core sitting right about in here. This is 4 p.m., so about tornado time. And if you do your cross sections, generally through the strongest spot. Seems like, maybe we were kind of nosing in out of the right exit into the right entrance region where you start seeing maybe a little bit more favorable severe weather. So kind of hit or miss. I actually thought this was going to be a little bit more southwest. So looking at this now, it actually seems pretty much on the ball, right ahead of the overall trough here, and seems like our area of interest was right in here today. So not too bad overall. Maybe a little wonky in specific location, but otherwise plenty fine here. Going down to 500 millibars, the one thing I do like to see when I'm looking for a severe weather setup is the strongest winds at 500 millibars are directly over our area of interest, so that checks our box. Love to see the strongest flow over our storms of interest, which seems to be the case here today. And going down 700 millibars, again, still out of the southwest. So we don't have too much turning of height at all through most of the profile until probably that lower level. Yeah, and then you can see here at the surface, we turn it again. And at the surface, if I can pull up 2 meter in wind, and yeah, you can see how you start getting these southeasterlies up into these bays here. So it seems like you had this localized area of a little bit better turning here, kind of over this eastern uh, DC area into the kind of bay areas here south of Philadelphia. So yeah, it's decent little localized tornado setup here. Nothing too crazy, pretty simple, straightforward stuff. And actually, I'm actually curious to see how did her nail this just off of reflectivity. Were there supercells there? And take a look at that. Boom. Supercell from the 18Z her right over Dover seemed to be the case. And actually, this is actually fairly accurate to what the radar looked like at the time. Very kind of sloppy multicellular system with a supercell kind of on the tail end of a makeshift bow here. So that's pretty solid for what actually ended up kind of evolving throughout the day here. But
The her is him in this case.
it's not, surprisingly not too bad. Not too bad at all. And just for the funny, I always like to see what did it show up in. Actually, funny enough, did highlight a slightly greater zone of higher STP values here. So I'm actually curious to see what the sounding looks like. And yeah, it looks like we've got a nice deep thermodynamic profile, lots of cape to utilize. Since there's not much dry air here, a lot of this cape definitely can be realized. Probably maybe up to about 200, 300 millibars here, but plenty tall storm, lots of deep instability. So you need a lot of storms here, given the overall deep moisture and not a lot of dry air. You need a lot of storms to kind of cluster together to develop a strong enough RFD. And yeah, no surprise with the hodograph shape. Really nice hodograph shape for strong low-level mesocyclones. A really strong surface vector here as well. So this is a pretty solid hodograph for a strong low-level mesocyclone in a very deep tropical-esque air mass here. So it seems to check the boxes for those quick hitting, maybe locally intense, strong. I shouldn't say intense. That's more EF3, but locally strong tornado or two if you can get the right chaotic mergers and storm behavior together to make it work. But not something I would expect multiple, like lots of tornadoes or prolific outbreak of any kind. But yeah, it seems to fit the bill for what it could have been forecast. Really solid profile, very tropical air mass with just a strong, deep, low-level shear. And yeah, seems like it got it done here actually by Dover. So rare win for the her nowadays. I feel like with how much we've been talking about how much that model has been struggling this year. Seems to be like a decent rare win here, kind of locally at almost roughly about the tornado time, if not the tornado time. So that's pretty neat. That's pretty neat.
Love it, Hunter. I knew you would be able to give us an incredible analysis on the fly, so really appreciate that. Got some questions backing up here in the channel as well. So from Jen, she wants to know, random, but what's your what's your favorite color and your favorite ice cream flavor? I don't have anything WX related to ask, haha. So Hunter, give it to
Hey,
us.
so I don't actually have a single favorite color. It is a three-way tie between a royal blue, a deep lush grass green, and I love amethyst purple. I cannot decide which one of those three I like most, but they are my favorite. And then for ice cream, I would probably say cookies and cream. There's something about cookie dough. It's just so good. It's good stuff. Probably why I'm a little heavier now.
Solid choices. That's just what happens when you're a dad. So I wouldn't be too rough on yourself there.
Actually, to be fair, all my weight gain was college based.
Shh, we're not gonna tell anyone. We're gonna call it.
Lots of stress, and not enough exercise. So
Yeah, we'll call it dad weight though. I won't tell anyone your secret.
I call it marriage weight.
So we have lots of people chiming in here to give some shout outs. Reed PWX over on YouTube, R Patterson 33 also on YouTube. Welcome both of you to the stream. Great to have you here. A lot of the criminals that we are used to seeing over on Discord. Jen, of course, we just talked about her. Leo Moral, Seymour 4198. I've got Radar Shark in there, so great to have all of you hanging out with us here tonight.
Yeah.
Looking at the chat just to make sure I don't miss anybody. So yeah, if you're hanging out, lurking and watching, say hello in the chat. I'll give you a shout out as well. And while we're waiting for some other people to drop some comments, Hunter, the next question is coming in hot from Radar Shark. Hey Hunter, I was watching a Skip Talbot video yesterday, and he was talking about how the inflow is pinched off when a tornado forms. And so that made me think, well, if the inflow is pinched off, how come some tornadoes are long tracked?
Yeah, that's actually a really good question. That goes into the basic idea of more so how tornadoes kind of die off, right? If I can pull up, because I'm a visual learner, so I like to draw, so please enjoy some of my drawing skills here. Go ahead. Y'all can see my beautiful gray screen here. All right. So basically, the idea of a tornado is simply you need to have this balance of outflow and inflow. So think of it like if however you want to like visualize this, but you need air coming in and you need a balance of air pushing around the tornado to make it work. So the idea is that in an RFD, it is a zone of relatively cooler, colder air that wraps around the backside of a tornado. So if our tornado's here, cold air will descend out the backside of the storm. That looks more like a smiley face. There we go. There's an arrow. And it hits the ground and fans outward in all directions. Usually the tornado would be ahead of this zone, which is why the RFD usually like hooks around like this. So if you look on radar, a supercell may look like this. That's a terrible drawn supercell. Maybe something looks like this. The tornado would sit in here. This is like what it would look like if you're on a radar. This is what if you're looking at the storm from the due south. So, we'll say you are sitting here looking this way. This is what you see, ahead of you. So this inflow balance is very important because what we've learned through scientific studies is that there is a narrow channel right about in here, kind of on the leading edge of the supercell, kind of between the forward flank and the open air mass, kind of out ahead of it, where the air gets funneled in. The RFD kind of funnels it in this way, kind of pushes into a narrow zone. It actually loops behind the tornado and then goes up into the mesocyclone. It's very important that this channel stays open. If at any time another storm blows up in the inflow region, even in the RFD, or slams in from behind, causing lots of excess precipitation to kind of fill in this zone, the RFD can entirely circle the tornado itself. So instead of looking like this nice hook, it may actually look more like a ball, like this, where now that inflow channel is displaced kind of more. Let me use a different color for this. Go back to the green. It's displaced more up here and can't actually get to the area that it needs to maintain the tornado. So in this case situation, the tornado would is what we call occlude or die off, weaken, rope out. Those are all different ways to explain it. But generally it means that the tornado no longer is supplied helicity or just natural energy for it to spin, rotate, and continue. So in the cases of long track tornadoes, our supercells maintain this balance of a strong RFD constantly while also maintaining an unimpeded, rich atmosphere out ahead of it. And that's when we can get the real monsters. A really great example that we had somewhat recently was obviously the Mayfield tornado and that supercell, which tracked from the initial updraft, blew up in southern Arkansas and traveled all the way. I think it even almost made it to Ohio by the time it actually finally died out as a rain shower. Crazy, crazy distance and produced multiple significant to violent tornadoes on its path. The Mayfield tornado being but one of them. But that tornado lasted, I believe, over 2 hours. just trucking along at 65 miles an hour. So yeah, it's a really fun example of meteorology going right or horribly wrong, depending on your point of view. But I think these cases are very fascinating because more so often in nature, this doesn't hang around all that often, right? It's very common we get very short-lived tornadoes. But in this case, we can sometimes get these rare situations of tornadoes that last way too long, and they tend to be very strong and large and just truck off on in any random direction at a very fast speed. So yeah, very fun meteorology when we get those cases. But it's just all about, do we maintain that inflow balance between the RFD and the inflow channel? And if that can stay nice and balanced, and one isn't overpowering the other, right? The inflow doesn't get too strong, or the outflow doesn't get too strong or too weak, vice versa, then your tornado could die. So yeah, good question.
I actually have a couple of follow-ups for you, Hunter, because I thought that
Sure.
was super fascinating. So you mentioned destructive interference, talking about some of the influences that can cause that inflow, that narrow band of inflow, to get displaced from where the RFD is wrapping around the storm.
Hmm.
Is that the opposite when you have constructive interference, like mergers, interactions, that sort of stuff, where maybe even a storm that is struggling to actually have enough inflow in the right place can all of a sudden be influenced and have that sort of, oh, I'm almost thinking of it as like that channel gets sort of tugged open by the interaction that's happening around the RFD, kind of
Hmm.
pulling that pinching effect away. So then there's a lot more opportunity for a big surge of inflow to come rushing into the storm. Would that be something that happens?
Yes, that actually, funny enough, happens a lot, and something that Cameron and Kyle, both other coaches and other great scientists in meteorology now, that are really looking into is how mergers affect tornado genesis. And the big thing they're finding is, yes, absolutely, nudgers, mergers, and other influences from other objects can heavily fix a supercell that is struggling to become strongly tornadic. We found actually, funny enough, that a lot of storms tend to often have some type of merger or some type of exterior influence to nudge into your storm or merge with your supercell that helps develop into a tornadic supercell. It's funny enough, the more we've delved into it, I at least think back of all the storms I've always chased, there's always been another storm nearby your supercell, right? We've always idolized the idea of, we want an isolated supercell, no other storms around it. And then you realize in reality that that thing never actually produces a tornado because it can never actually generate a strong enough RFD. And very seldomly do you get supercells that are just strongly tornadic purely by themselves with zero outside influence. And funny enough, a really good example from this year, I know this year hasn't been necessarily the amazing last couple of years that we've had. But a really good example was actually the St. Liberty tornado from earlier this year in May, where actually the supercell was kind of struggling to produce a tornado, but we know a very violent tornado, potentially violent tornado occurred. And what happened was, is the tornado began, the supercell was able to undergo that tornado genesis, but at the same time, the cold front that was supposed to kill everything off hit the backside of the mesocyclone at the same time. And we actually have radar proof of that that impact of the cold front may have actually helped intensify the tornado and helped it become a much more intense tornado than maybe it could have been without that type of influence. Now, the unfortunate part is it is a cold front. It will win. It is the dominant factor in all of meteorology, and it eventually undercut the supercell, and that was the end of that supercell. But there was decent radar proof that that tornado genesis was aided by that impact of that cold front. And I think that's pretty neat. I think that's kind of a new fun thing that we have in the current meteorology science.
Yeah, absolutely. I mean, it's just fascinating that we did idealize that lone supercell with access to all the inflow for so long without stepping back and realizing maybe that's not actually the case.
Hmm.
Maybe we do want something in the vicinity. And the way you described it, I'd heard everything that you had shared basically so far, but I had never put it together until I saw the visual. So give yourself a pat on the back because your whiteboard skills are apparently second to none. I get it now. I understand completely why that's important, and just yeah, it's great to be able to visualize that.
Yeah, it's very fascinating stuff. And I'm going to loosely quote Cameron on this, but It's just one of those, wow, I actually finally started just looking around and noticed something and was like, huh, that's neat. Has that happened before? And then realized, oh my gosh, look at this whole list I've built. And thus now we have new research from Cameron. So, yeah.
Yeah, man. Observation. Whether you're talking about on the morning of a storm chase or whether you're just talking about in regular life as you're looking back at data, getting out of that left brain, everything is already systematized and categorized and already solved mindset is definitely the route to new discoveries that are going to take you places you've never been before.
Yeah, and actually the funny thing is if you ever read some of Cameron's publishing for this topic about nudgers and mergers, I think he even specifically quotes in here. I've heard him tell me this multiple times, but I think it's quoted even in literature, is just the idea of, hey, everyone else talked about another storm influencing the storm or being nearby, but never actually looked into it, and I'm wondering why.
Yeah.
So sometimes it really is just, get it, like this is so simple. Another storm hit another storm or was next to another storm the entire time it produced a tornado. That seems like a simple observation, but is turning out to be very impactful. And I think that's the important fact is like sometimes we want to find the super nitty-gritty details to figure out things, and sometimes a simple observation goes a long way to understanding some more of the complexities of meteorology.
Speaking of meteorology, I just had a crazy storm. I was like looking around, wondering what was happening. Uh, Storm. I don't think it's a supercell. It's more like a because I'm in Columbus. There's not really a risk for that today. But I'm looking at the radar right now. It's like a crazy heavy water loaded summer thunderstorm popped up right over my house. Just started dumping buckets of rain right over top of me. So
All right, chat, we're gonna dox where Gabe lives. Let's find the three thunderstorms in the air. No, I'm just kidding.
oh shit, that's dude, that's so funny. I'm pretty. It would be even funnier, but I have shared my location many times by screenshotting with my little location dot on. So the more investigative we oriented folks could definitely have figured that out. But yeah, if you guys look at the storms in Columbus, there's not a whole lot of places I can live. So
No,
take a peek at that if you want to.
it narrows it down. There's like five storms, so good luck, everybody.
And if anyone wants to stalk me, bring it on. I'll
Yeah.
take you out. Leo Maroney says Ohio mentioned. Yeah, Ohio doesn't exist, Radar Shark. You're correct. This is
Oof.
all a fantasy. Spencer Barrett, nice to have you here. I think this is the first time I'm seeing you in chat tonight, so welcome aboard the ship. We may be sinking, but we're going to have a good time before it all goes to hell. Next question. Coming in here from Kazaki, one of our OGs from way back in the day. What are your thoughts for Eastern Nebraska tonight? I have been trying to figure out why the SPC put a 2% for Lincoln. I've been looking at models for overnight and into the morning. I'm just not seeing much. He says he doesn't see a lot about the surface-based cape or the thermodynamics. Might be a cap in place. So yeah, maybe if you want to take a look at specifically Eastern Nebraska tonight, what are you seeing? Why has the SPC outlined what they've outlined? And maybe you could shed a little light as to how the situation may evolve as we get a little bit deeper here into the evening.
Yeah, let's go ahead and do it. Let's have some fun. So, got our good old pals weather front over here again. So, just a good forecast tip is always start with what's actually happening, right? So, we're talking about a potential tornado risk kind of in this general area. And actually, let me go pull up the actual official outlook here. Looks like they've got a 2% risk kind of draped across the general area, pretty much from northeast to southwest back into Nebraska. So it seems like they're saying a very low risk, slight risk, a 2% risk of a tornado. Probably only one tornado, maybe two, kind of very isolated in nature, I would imagine, without even reading any of the text. That would be my initial guess based off of this, which is pretty typical for SBC forecasts. So let's actually take a look right now. So first things first, the one of the big important factors that's important to forecasting severe weather is, do we get storms? Well, check. We got storms, and more importantly, these are supercells. These are well-defined, easily identified supercells that are in progress, and actually a fairly impressive long supercell here by Sioux Falls. This is a really great area to storm chase, by the way. I love this zone of the country. This is a beautiful place to storm chase, as long as you can find river crossings. That's my only stipulation. So aside from that, this is looks like we got our supercells and just some basic kind of what's going on around here. This is some REMTA. Looks like we have some 70s dew points kind of nosing into the area, so we've got plenty of instability. Looking at theta E over 350 degrees, or I did the cardinal sin of saying degrees. It's not degrees, it's Kelvin, but you know. Uh, Plenty of instability here. Lots to work with for our thunderstorms. And nice, decently strong southerlies at about 10 knots, about 15 miles per hour, generally speaking. So looks like you got some pretty solid flow kind of in the vicinity here. Let's go ahead and jump over to our friend the Wrap here. We're going to look here now at what's the latest run we can do? We'll do 23Z, just the latest Wrap run we got. So we're not going to look at composite reflectivity. We're looking at just the general synoptics here. So let's go ahead and start from the top. First things first, we got a nice little short wave that is moving through the area that has already actually made it generally through. You can see that this short wave kind of extends in here, and actually that color is terrible. My apologies. Let's do white. It's a little better. You can see that there is a little bit of a shortwave trough that has already kind of progressed its way kind of through the region. And now we're just in a predominantly strong belt of flow, pretty much just sitting here from the northwest across the whole region of interest. So, you know, we've got flow. There's no real need to do any jet analysis here because we're pretty much just smack dab over the area of interest. And we're obviously looking at eastern Nebraska here. So we're pretty much just all smack dab in the risk here. You could do the jet dynamics, and we'll do it just for the sake of learning. Generally speaking, this is about what it is. So right now, all of East Nebraska is sitting in the right exit region, but this kind of coveted area of the right entrance region that helps kind of favor a little bit better rotating storms seems to be kind of nosing into the area of interest. So maybe that's going to be something that helping to support the development of stronger rotating storms. And actually, now that I'm taking a little bit closer look at this, maybe this Jet Max is a little bit more like this. And again, drawing the overall, quadrants maybe a little bit like that. Seems like we are getting into that, this right entrance region here. So we're getting a little bit better lift aloft. So that's something important to know. 500 millibars. Strongest flow seems to be coming right into the area of interest. Again, highlighting here, eastern Nebraska. This is going to nose right into our area of storms, which are already ongoing right in here. So that checks the box as well. 700 millibars as well. We got a little bit of flow, kind of weaker hanging around here on this backside right now. Stronger flow seems to be relegated much more off to the north here, kind of closer to the main long wave trough kind of here. But there is some type of wave still kind of hanging around, I guess. But there's noticeably some flow kind of in the area. 850 millibars, I expect some low level jet. There's some noticeably weak, so I don't necessarily think this is going to be crazy robust. I am curious to see how this progresses into the night. And actually, funny enough, I just realized that this was looking at 7 a.m. tomorrow, so everything I just talked about is entirely wrong. So let's go take a step back. We love having some fun here. All right, so overnight, seems like that trough that I said was probably a little bit too far east is actually still being involved here. We'll get about 10 p.m. tonight. That shore wave is still sitting about in here, so hey, that checks that box. That's why that felt a little bit off. So it seems like it's right in the right area. So we've got lift arriving, 500 millibars. Again, stronger flow is over the top, so we seem to check the box as well. Moving down 700 millibars, that looks much better. There we go. Flow's not randomly displaced. We've got nice 700 millibars from the northwest, along with this short wave, which notice again, as I've been stepping down, notice how this stuff is being overlapped the same area of interest, which is a good sign for organized severe weather. 850 millibars. Yeah, again, not too much of a low level jet. Seems like the response is still kind of lagged over here into the central plains. So not too much of a low level jet to necessarily worry about. So you won't see these super enlarged photographs, which might be a slight negative to a more robust tornado experience tonight. And going ahead to the surface, dew points here at 10 p.m. Again, no surprise, we've got nice southerlies here at 5 to 10 knots, getting up to that 70-degree dew point mark. So no surprise, it's summertime, and we see plenty of moisture and stability. But notice, after we've done this by 10 p.m. here, we're kind of getting this little overlap zone kind of in here that seems to be maybe a little bit favorable, at least in the near term, for maybe some supercells and some tornadoes. So if we go here to one of the things I love to look at is bulk shear. Let me go ahead and kind of clear this stuff so we can kind of reset. 0 to 6 kilometer shear here. One of the amazing things I love to see if I'm looking for supercells is the overall wind shear to the initiating boundary, which, again, if we remember from the radar, looked a little bit like this. Pull up this, there we go. Seemed to be a little bit like this. And if we go back over to model land, we see that our wind vectors here are very much perpendicular to the initiating boundary, which should absolutely help the development of supercells rather than a mixed mode of convection or a squall line per se. So this is no surprise. This is very strong deep layer shear in the region. And actually, if I go over here, I am curious to see. Might have to go over to the HER for this. There we go. Seems like the HER is a little adamant about the storms being a little bit more southwest, but trying to pull a model run, which I don't know if they have the HER doing doing soundings like I just pulled. I don't know, I just pulled a sounding. I don't know what I'm talking about. Well, there's storms there. Trying to remember. I am still learning how to use this amazing platform. There we go. Got it. So by 10 p.m. here, let's go ahead and actually pull up this again. I'm going to use instability because I want to see kind of where all the instability is sitting. So the big one that this is all, let's go to 10 p.m. here again tonight. So you have that MCS that's currently ongoing. You know, that big supercell kind of MCS combo is going south through Nebraska right now. So this guy is showing that this pretty much nukes the environment, and then these guys are probably going to continue on. But funny enough, the latest HER here does not really mark this convection very well. If I go up here, yeah, it barely even has this convection ongoing. So this is an important thing to note that even this model is a little unsure, at least off the latest run, what's going to happen with these guys. But it marks off the obvious complex, moving southward towards I-80 and then dying off. So we can imagine that even though the model doesn't have an idea of these storms, we can still, start queuing into what that environment might look like, given the fact that we do, in fact, have discrete supercells here that are all looking pretty solid, pretty nice right now. Go ahead over to models. We'll go ahead and go back to 10 p.m. here. So we assume that those storms here are going to be probably a little bit more towards the Norfolk, maybe Columbus area, Sioux City area. So we're going to go ahead and just pull a random sounding here. Let's take a look at what the environment's looking like at about that time. So, as the one person pointed out, the first thing I immediately caught my wind of is a pretty solid inversion that does develop here due to some strong, warm air here right above the ground. I do wonder if this is cooling a little too fast, and I wonder if this is a little convectively contaminated based off of that big MCS rolling through. And a good way to check this is let's actually look at temperatures, see kind of what's happening. And yeah, I think there might be a little issue with what's actually ongoing right now out over eastern Nebraska. So let's go ahead and actually look at observation. What's actually the temperatures out there? Seems like we've gotten into the 80s here up here, but I do notice that this area of eastern Nebraska is a little cooler, so maybe the model actually might be onto something. Going over here, yeah, seems like the model actually has everything a little bit warmer. Oh, this is actually tomorrow. Gosh, this slider thing is going to get me every single time. There we go. Yeah, so the model thinks it's actually a little bit warmer than it actually is, which is a little bit neat to know. Looks like there's a few degrees difference between the overall observations and models, and that's an important thing. So the person who asked the question about maybe some severe weather, tornado or two in Nebraska, given the fact that temperatures are running maybe a little bit cooler, and another thing I want to check is look at how much the satellite is showing how much cloud cover there is over eastern Nebraska. But notice where the storms are currently existing, there definitely was not heavy cloud cover previously. So that's probably aiding in the storms rocking and rolling here. But with the sun setting, this area is not going to destabilize all that well. And with the nocturnal inversion developing, we'll probably see maybe these storms probably die out once they get into northern, northeastern Nebraska. I think the tornado threat probably for them is probably going to be in the near term, from now till about 10 p.m., kind of maybe in this zone here at most. I think further south, you're looking at whatever this complex here does, which should just be continuing southward until it dies out. All of this is basically huge cloud cover that will never allow a single storm to form underneath it because, and another fun aspect of meteorology, clouds help to define zones of lift and suppression. A thunderstorm tower is massive vertical lift, right? Each of these towers are providing updrafts. Well, when you bubble something, right, you get these rings of when they hit the stable air. So we call them gravity waves and whatnot. This can also induce downward motion, right? Because you have to have equal in physics, right? What comes up must come down. And in this case, this actually generates suppression generally around the thunderstorms as well. So a big complex like this is going to be providing tons of naturally suppressing air in this zone. So this area of Nebraska probably may be relatively tame tonight. We'll have to see kind of what this complex does as it overall moves southward with multiple supercells here, at least in the short term. But I'm not too particularly excited off of this. Look, if I was storm chasing this and I was sitting in Columbus, I wouldn't be necessarily too excited about my tornado prospects. But I'd be very curious to see what these storms look like at dark, looking for lightning, maybe some storm structure as these storms become a little elevated and moving into big pockets of heavy inhibition. Maybe they'll turn a little smooth and actually get nice and pretty looking for those kind of in the area. So if I was in the Norfolk area, I'd definitely be paying attention to what happens with these guys. But if you're in Grand Island or Omaha, Lincoln, I'd be a little less concerned for tornadoes, but maybe some severe weather still could be possible in the form of damaging winds or hail through the night as these storms kind of progress through the area. So, yeah, kind of a fun little case example. I do think hail and probably damaging winds are more so the main threat in this area, but maybe a small nod at a tornado or two, either somewhere in kind of this region here, or you get lucky with another tornado with this kind of complex of storms down here.
Hunter, that was really good. I don't know if anyone's ever told you this before, but you might have a career in meteorology
What
if
a
you
concept. What a concept.
yeah,
I'm
man.
going to look into that. I'm going to go see if a college will accept me.
Well, I mean, you might even be able to someday get a job working at a company that values your forecasting skills. So
Ah, big dreams, big dreams.
big. Oh no! First thing I see when I look over at chat is law enforcement confirmed tornado. That
Where
is, I think people are making a joke out of the common trope of the law enforcement confirmed tornado is just like a single little wispy cloud in the sky, and
Yeah, I want to believe that all emergency management are capable storm chasers, but that is not the world we necessarily live in, and that's okay. Everyone, learns. Not everybody is a big weather nerd like we are, right? We all start somewhere.
Leo Maxwell showing a video of some nice towering cumulonimbus that he got earlier today, and I was noticing the same thing here in Central Ohio. It was actually beautiful when I went out for a couple of hours earlier today. All around me, everywhere, just really beautiful cumulonimbus clouds that had blown up. And the nice thing was because there was very little shear to ruin the party, nothing was bleeding into one another. So it's just one of those like really crisp, beautiful days where they're just like spotting the landscape, and
Hmm.
thought it was really, really cool looking outside.
Yeah, no, I love the summertime when you just get the basic thunderstorms. Yeah, they might not be all that impressive structurally, or they're not super bad at like producing tornadoes or whatnot, but they're pretty to look at, right? It's still convection, and we love convection around here.
Seymour 4198 says, I just want some rain. I'd chase it at this point. I feel that, Seymour.
You want to
I
what?
feel
Me and you, buddy. Me and you. You want to know what? Here, look at this. I'm gonna pull up something. All right. You want to talk
TD.
about needing rain? You ever heard of the drought monitor? It's a really great thing, and I could prove how much I'd need rain over you. You ready? Ready? How much rain I need? I mean, I have no idea where you
PDS
live.
downdraft is what he's going after.
PDS downdraft. All right, here I am in good old Colorado. I live in Weld County. I am in extreme drought. I am, according to other NWS databases, 3 to 4 inches below average where I should be. And I hate my life. My garden is sad.
Oh no, that's right, man. Because now that you're a dad, you have to care about lawn care.
Fortunately, I don't have to mow my lawn, but I do have a garden I tend to, and some of my plants are very stressed, and it makes me sad. Okay? I need rain. I'm sure both of us need rain, but I need more rain. Okay.
Yeah, man. Seymour 4198. I bet you don't have a garden. Maybe he
Ooh,
does though. Maybe he has a
yeah. I'm
garden.
sure he's got a better garden than I do, and I'm just a pansy.
Don't you just want to jump into the fluff? Says Leo. Yeah, man. I love it. Absolutely love it.
Oh, one of my like bucket list things is skydiving into an eye of a hurricane.
I hope you
Because
know.
why
I'm
not?
guessing. I'm guessing that should be the last item on your bucket list.
What do you mean? It's calm in the center. It's perfectly fine.
Good. Best of luck.
It'd be fine. There'll be a boat to pick me up. As long as you stay in the eye like the birds, you'll be just fine.
Just fine.
And then when you
Sh-
run into land, you just run into a building. Easy.
yeah, dude.
Perfect.
Surely nothing can go wrong here.
I mean, if you even just have a basic sailboat, just ride the edge of the eye wall where you hear death. Just don't go in there, just ride the edge of it. You know, you'll just constantly do loops around the eye, and you never have to use any electricity, and you just keep going. Perfect, no problem.
And our boy Seymour has gotten back to us, and he said, "No, I don't have a garden. I have a rainforest in my backyard with 8 foot sunflowers because it is not tended to properly." So, the guy's got Jurassic Park
Perfect.
growing in his backyard.
Perfect. Good for you. Good for you.
Over on YouTube, I see BBNXXY. We're doing smash burgers tonight. So,
Ooh.
making dinner while listening to us goobers go back and forth.
Smash Burgers is good. 10 out of 10. If I was on a storm chase and found them, I'd be very happy. Very happy.
Radar Shark, you dropped the gift that I was thinking of. I was actually gonna do a clever girl reference when Seymour mentioned what his backyard was like, but I didn't know if enough people would get that. So good, very good that you dropped that gif. Love it, man. All right, let's see if we have a couple more questions. I am going to be shutting questions down here in just a moment, so if you haven't got it in yet, then go ahead and make sure you drop it in the chat right now. Remember, the only thing is you have to be a channel member either on Discord or YouTube to get your question answered on air. So, Radar Shark wants to know any tips for chasing cold core setups?
Yeah, yeah. Cold core setups are they're really fun, but they're different than traditional tornado chasing. And back to the whiteboard. Perfect. Welcome back, class. It's whiteboard time. All right. So, biggest thing about cold cores is understanding fundamentally how do they work. It is basically you have a low pressure that is aloft and at the surface that are vertically stacked. So think of it like if I can get a different color here. So we'll say, ooh, that's huge. Let's start this over. There we go. We'll say this is 300 millibars, 500, 850, and then right here at the ground, we don't need any upslope. Sure, whatever. Surface, right? You'll probably see this on weather maps where you'll see different troughs and ridges and whatnot, right? Low pressure, high pressure centers. And how it generally looks is height lines will behave like this. And they get less and less deep as you get towards the surface. If you get a vertically stacked system, it means that the low pressure at this level, and this level are generally in the relative same spot vertically. What happens is then is you develop some interesting things at the surface. Let me go ahead and delete all this. So now we're going to look at it from a top-down perspective rather than horizontally. I'll delete this all by hand because it's not as fancy as Weatherfront. There we go. So basically, if you're looking on a surface map, your key features like boundaries are going to be extremely important. Oftentimes, when you're out chasing in the plains, right, you'll chase like a dry line and whatnot. Imagine this is your dry line, and you get your supercells to kind of form off of it, kind of like this, right? And they progress off to the east or northeast or whatnot. That's more of a typical, maybe it's cold front based, cold front is hanging out back here and that kicks off the storms. Or maybe there's a warm front that kind of drapes in here that you're trying to chase the storms that they run across it, right? Lots of different ways you could chase supercells and tornadoes. But for cold core, you're very specifically looking to be underneath the important pinch zone that is generated by the merging of boundaries underneath that low. So what that might look like at the surface is you've got your surface low pressure that sits here, right? Maybe you're looking at a surface map. Your cold front will extend kind of off like this. And actually, I'm going to draw this a little bit differently. It goes like this. Your warm front will drape off like this, just vague drawing. And then you have this very key boundary called the occluded boundary that kind of tugs into the low. If you get a vertically stacked system, that means you'll have very cold air aloft. And that's very important as that helps generate very steep lapse rates and large instability, especially large low-level instability, because if you have very cold air aloft and warm air nudges right underneath it, you'll develop a lot of instability. So basically, you want that cold air to overlap your warm sector, kind of like this, and you want your overall system to be strong and closed off with height as you go up. If you get this overlap zone, it's very easy to get what are called these cold core-esque tornadoes because they are not supercell based almost ever. Sometimes you can get a supercell that kind of runs into this boundary, but oftentimes you'll actually get kind of blobby storms that kind of form along this, and then you get more of your traditional supercells, down in the open warm sector like this, and then maybe a line of storms down like this. When that cold front catches up to the warm frontal boundary, you get this nice pinched off zone right in here. In this zone, storms could be completely elevated, roll across this zone of strong vertical shear and horizontal shear, and that can help induce tornadoes. And oftentimes, storms that form in this zone are very weak, they're very blobby, they're usually not very impressive visually, which can be kind of a deterring factor for you if you're out chasing, because you look at this and go, look at this supercell, look at this warm front that they'll run into, and the nearest surface station, is sitting off down here. And it's reading, we'll say like cold core, so we'll say this is in April or maybe early May, and it's like 82 over 53. And you're like, that's probably not going to make a tornado. But, it seems like a decent environment. There's big shear. Maybe we'll get a cool supercell. And that's the big catch that everyone kind of gets caught into. But up here, you get, winds that are kind of coming this way into the low. And on the backside, they're coming this way. And so you get this nice tight shearing zone that you want to basically target. So with traditional storm chasing, you target a storm in a favorable zone. In this case, you're targeting just the zone by itself. And for example, funny enough, if you see this picture right here, this is the Spalding, Nebraska tornado. This is a great example of a cold core tornado because, it's like one of the best I've ever seen for a cold core. Because it was a quarter-mile wide wedge-shaped tornado that was actually surprisingly strong because you overlapped both some very strong instability with a lot of shear in the cold core aspect. So it's kind of a fun combination of both. So you got the best of both worlds. And these storms will often move northeast or sometimes even north or north-northwest. And they can be really funky to storm chase. You need the right conditions, and this can vary generally with time and based on a particular system, but you're looking for being as close to that center of low pressure, tucked right in on that boundary, looking for that strong shearing point and seeing if instability gets in there. You want to see lots of sunlight. If you see lots of cloud cover, it's not going to work. Look for boundaries baking in the sunlight through the morning hours. You want to see that instability nosing right up in there, and you can have some really fun things go down. So cold cores are one of my favorite to chase because they are relatively safe to chase. There are usually no other hail or wind hazards, usually on more traditional cold cores. Maybe there's some hail, but I've never ran into really serious hail in these storms at all. Most of the time, it's just heavy rain showers and then a chance of a just epic tube tornado. Those are really fun to chase. Those are the tornadoes that I really love to get close to because they are fairly predictable, very weak, very wispy, laminar looking, and I think they're fun to chase. So, good question. I hope this kind of helps understand how these setups work and kind of what to look for.
Excellent analysis once again, Hunter. Cold core, by the way, I think is really cool because what it does is reinforce the idea that everything in the atmosphere is relative. There is no absolute hot or absolute cold. It's all about the ingredients, the air masses, and their relation to one another. So you can have a day that you walk outside and think to yourself, I got to go back in and put a hoodie on. And that could actually end up being a cold core day that works out quite nicely. And so it's a good reminder of everything being relative in the atmosphere.
Yeah, and actually, funny enough, I also chased the January tornadoes in Iowa. Well, I believe it was in 23 when they happened. I saw two tornadoes in Iowa in January, and it was 50 degrees when the tornado occurred. The dew point was in the mid 40s, and the RFD had snow. It was this
Is that
weird
the
hybrid. It was this weird hybrid of snow, grapple, and rain that it didn't quite figure out what phase to be in. But when you drove behind the storm, the entire road was covered in white, which was both grapple, hail, and a little bit of mix of snow. It was a very weird little storm chase to see a tornado and then have it be borderline snowing on me.
Yeah, man. Is that the mythical Snoper cell?
Yeah. No, well, there are sometimes you can actually get. I saw a number of years ago at this point of a water spout that happened near Pueblo, Colorado, while it was entirely snow covered. But because the lake was warmer, you got just localized instability, and there was a little water spout that developed. So they can happen. It's all about just is there instability, right? Doesn't matter if it's really cold or really hot, as long as there is just vertical motion, shear, and instability. You can get fun things to happen.
Last thing before we bounce out of here, I'm gonna actually do a little bit of a confessional for a moment, if you wouldn't mind being my stand-in priest. So a few years ago, there was a huge blizzard in Buffalo or the Buffalo area. And I thought it would be funny, and that there was no way anybody could possibly see it as anything but funny if I went back through the archive of the warnings that had been issued and found a Buffalo warning from like years ago, and
Hmm.
I quote retweeted it, because back in the day, I don't know if it's still the case, but quote retweets, they hide the date of the actual tweet unless you pop it open to look at it. And I
Hmm.
quote retweeted it, and I said, crazy snow NATO ongoing right now in Buffalo, as they were getting like 4 feet, 4, 5, 6 feet of snow. And man, when I tell you that people got mad at me, people got mad at me. They're how
Yep.
dare you? Like it's you're gonna cause false alarms, and I'm like, how on earth could you ever think that was anything but a joke? There's like 4 feet of snow on the ground. There's no tornadoes in Buffalo right now.
My favorite on that same vein, and I'm not going to name names. You probably will figure out who it is, but I think it's funny when you'll have an active tornado event in an area, but it's like not all that impressive, but it's like modestly hyped up to be, and then people will post past tornado videos that they've chased in that area for the engagement.
Yeah,
I'm like, you're dirty for that, but it's funny. But you're
it
dirty
is,
for
dude. It's
that.
always funny. I got the idea actually because there's a guy that I don't know if he still works for Barstool. I think he does, but his name was Uncle Chaps. He's widely loved in sort of like the alternative sports journalism community. And one of his claims to fame back in the day, I'm talking when he had like under 20K followers on social media, is, and this was the Wild West of Twitter, he would change his profile picture and his name and his username so that, like, if it was like, let's say it was like Josh something 1, 2, 3, 4, 5. He would change it so that the O was just a zero and make it all capital, so it looked the exact same unless you really analyzed it. And then he'd change his profile picture to that person's profile picture, display name to their display name, and then he'd announce something crazy like Kevin Durant was just traded to the Wizards or something. And before anybody would know what had happened, it would blow up, and he would have like 100,000 impressions and like 20,000 likes, and there'd be people in the comment section going nuts, like he's a fake, he's a fraud, like stop it right
Yep.
now. And so I can't claim originality for that idea. I definitely borrowed it from Uncle Chaps, and
Yeah.
That kind of stuff is
Good
so
old
funny to me.
engagement. Good old
Yep.
engagement.
Engagement
Setting the
baiting, I
bait.
think, as the kids call
Yeah,
it. Yeah, as the
setting
kids
the
call it.
bait.
So, all right, Hunter. Well, really appreciate you taking some time to hang out with us here tonight. Also, thank you to all the folks on Discord and YouTube who hung out here with us. You guys are awesome. You make the show what it is. And of course, we will be back next week with another SCC Live episode. Take
Yeah.
care.